The first problem here, what is the static head at a residential supply line if the level in the elevated tank is 155 feet and the elevation of the supply line is 956 feet? Remember, static head is equal to the source elevation minus the distribution elevation. And so we have 1,045 feet minus 956 feet, which, typing that into your calculator or doing it by hand or in your head, whatever you want, 1045 minus 956, you get 89 feet ahead. All right. If the supply line is 880 feet and the elevation of the tank is 924 feet, so again, the static head is 924 feet minus 880 feet, and you get 924 minus 880, you get 44 feet ahead. All right, so pretty straightforward problems there. On to section 2, static pressure. So again, I've given you the key information here that to convert from feet of head to PSI for pressure, it's dividing by 2.31 feet. So the static pressure is 48 feet of water. What's the pressure? So 48 feet divided by 2.31 feet per PSI, just to show you how the units work. You end up, again, doing this in your calculator most likely. 48 divided by 2.31, you get 20.779, which you can essentially round to 20.8 psi. Okay. Calculate the static pressure of 1A. So remember, 1A is 89 feet. So 89 feet divided by 2.31 feet per psi is 89 divided by 2.31, 30.5 psi. And then calculating the pressure from 1B, 44 feet divided by 2.31 feet for psi, 44 divided by 2.31, you get 19.04. So you could say 19 psi. All right. So sections 1 and 2, pretty straightforward. Now we're going to go a little bit further with this. Still nothing crazy in part 2. Again, still working on water pressure, very similar to part 2 there. But we're kind of doing a back calculation. So how far above the supply line in a tank must the water level be in order to provide a minimum pressure of 50 psi? So now you know the answer. So instead of having the head and calculating the pressure, we have the pressure. We want to know what the head is going to need to be. All right. So 50 psi, and instead of divided by 2.31, it's multiplied by 2.31 feet per psi, because again, the idea is that the psi's divide out all that's with is feet. And so if you do that multiplication, 50 times 2.31, you should get 115.5 feet. Okay. How far above the supply line in a tank must the water be in order to get a minimum pressure of 62 psi? So 62 psi times 2.31 feet per psi is equal to, you get 143.22. And let's see, how far above supply line must you be to get 80 psi? So again, 80 psi times 2.31 feet per psi. 80 times 2.31, you get 184.8 feet. All right. So again, relatively straightforward answers to get all of this. Okay. Now, so we're going to try to finish through part 11 here, and then in our next section, we're going to go over the last handful of problems here. Okay. So let's see, section 4, fluid lines. Remember, as the water travels through a pipe, friction inside the pipe slows down the water and decreases the final pressure, PSI, at the faucet in your home. Right. In addition to straight pipe, every elbow T valve further increases the friction, meaning reduces the pressure. So, why is the concept of equivalent length important? Why is it important? Because pipe is not straight from source to house, but Hazen-Williams formula assumes straight pipe. So need to convert, I'll put that in quotations, fittings to straight pipe. Where can you find the values for equivalent length? That's your Hazen-Williams charts. All right, try to show those to you real quick. See if I can get to those quick. That's these charts right here. All right, it's in your packet. If you don't have them, you can always Google them. So just show you that real quick. Let's see. Hazen-Williams charts. Choose that one. And should be able to find the stuff. So here's a whole bunch of information. That's the Wikipedia stuff. Let's see. Let's even go further and say PLTW. That way we know we're getting exactly what we're looking for. Hazen-Williams formula sheet. There we go. So if you go to the end of this, that's what you're looking for. Okay? Just a little side note in case you lose track of stuff, how to find it. All right. What two factors contribute to total length? You have the most obvious, length of pipe. And then we have number and type of fittings. Okay. All right. So let's go ahead and start the process. We're not going over the full how to calculate all the pressures and everything. We're just looking up, using that chart that I had and showing you how to calculate the equivalent length here. So in numbers 12 and 13, we're only going 12, 13, and 14. We're only going over the actual how to calculate the equivalent length. All right, so we're going to finish that out. All right, so in number 12, if you go to we have 10-inch cast iron flanged water supply line. And then we have 7 90-degree elbows. So there's 7 90-degree elbows, 3 line flow T's, 11 branch flow T's, and 6 gate valves. All right, let's write that in, 6 there. All right, according to the table, again, for 10-inch pipe, a 90-degree elbow is 14 feet. A line flow T is 5.2 feet. Looking up for the branch flow T's, if you want to take the time. Oops. So let's see. Branch flow T's, 10-inch. You see you have 30 feet right here. All right. So that's 30 feet. And then a gate valve is, so that line down there is gate valve, 10-inch. You have 3.2 feet. All right. Multiply across, 3 times 5.2, you have 15.6. 11 times 30 is 330.0. And then you have gate valve, which is 6 times 3.2 is 19.2. Adding these all up, you should get 462.8 feet. Remember, this is only the equivalent part. This is not the total, because you would still have to add in the actual length of pipe. All right, so let's do a little bit more of the work here. So we have a 12-inch flanged cast iron pipe here. So 12-inch cast iron. So we have 90-degree elbow, and 4 of those, line flow T, and we have 2 of those, branch flow T. We have 6 of those, and gate valves, we have 3 of those. Going to the table, I'll kind of just speed this up, but I'm not going to kind of go back and forth. You can look it up your own. 17 feet for 90-degree elbow. A line flow T is worth 6 feet, or is equivalent to 6 feet. A branch flow T is equivalent to 34 feet of pipe. And the gate valve is equivalent to 3.2 feet. Doing the multiplication here, you have 68.0 feet, 12.0 feet here, 204 feet, and then 9.6 feet. Adding those all up, you get 293.6 feet. Okay. And the last problem we're going to do in this video is number 14. So, neighborhood water delivered to each home from a tower just a few miles away. We need to be able to account for these things. For the water to reach the home, it must travel through 4 90-degree elbows, 2 gate valves, let's see, 3 swing check valves, 10 line flow T's, and then 5 branch T's. Okay. All right. So when you have an 8-inch cast iron pipe, so again, looking up the table, make sure to look at the 8-inch portions. 90-degree elbow is worth 48.0 feet. A gate valve is worth 6.4 feet. Oops, sorry. These are the final numbers. I apologize. A 90-degree elbow. Let's see if I can correct this. Oops, that's a highlight. There. That'll be better. All right. 90-degree primary elbow is 12 feet, gate valve is 3.2 feet, swing check valve is 90.0 feet, line flow T is 4.7 feet, and the branch T's is 24.0 feet. Multiplying across, you have 48 feet here for your 90-degree elbows, 6.4 feet for gate valves. Swing check valves, for 3 of those, you get 270.0 feet. Line flow T's, you have 47, not 4.7, 47 feet. And then branch T's, you have 120 feet. Adding those all up, you should get 491.4 feet. All right. And that's what we have for this portion.